This video will focus on adding fractions greater than 1, connecting drawings to the algorithm. So we're going to look back at 1 and 2 6 plus 3 6 again. As we know, the sum is 1 and 5 6. So we're going to look at how that connects to the algorithm using models. So I have 1 and 2 6, so we have a mixed number plus a fraction, and I represented 1 and 2 6 over here. One thing that's important is that when you're adding numbers, because fractions are numbers, is that we keep the place values lined up. So when you're adding whole numbers, you keep the ones and the tens all together, the hundreds together, the thousands, and so on. Same thing here. You keep your fractions together and you keep your whole numbers together. So I have 1 and 2 6 represented, and I want to add on 3 6. So this is 1 6, 2 6, 3 6. So now you can see that I have 1 whole and 5 6. Now one of the things that you would have noticed is that the denominator stays the same. Okay, so when I'm adding with like denominators, my denominators stay the same. I'm still dealing with 6 as the size of the parts. And then I'm basically adding my numerators. 2 plus 3 is 5 6. That's where I get my 5 6. And then 1 whole plus 0 wholes is 1 whole. Okay, so basically when we are adding fractions, our denominators stay the same. First of all, we got to make sure they're the same. And if they are, it stays the same. And then we add our parts. And we can see with the model why that works. Now let's look at adding a mixed number plus a mixed number. Okay? So we have 1 and 2 eighths plus 1 and 7 eighths. And we know that it's going to equal 3 and 1 eighths from the work we've done earlier with the models, number lines, and everything. So once again, we want our place values lined up, our fractions are lined up together, and our whole numbers are lined up together, okay? So I represented 1 and 2 eighths, and then I want to add on 1 and 7 eighths. So if I go ahead and add on, I'm going to go ahead and add on my whole here. And then if I add on 7 eighths, that's 1 eighth, 2 eighths, 3 eighths, 4 eighths, 5 eighths, 6 eighths. Now I see that I'm going to have to add another whole and break it into 8 parts. And then I add on my last eighth, which is my 7 eighths. So we can see that where I get my final answer of 3 wholes and 1 eighth. But if I'm connecting it to my algorithm here, I can see that 8 of my denominator is 8 because that's how many parts it's broken into. My denominator stays the same. So I had 2 wholes, and if I added on 2 1 eighths, and if I add on 7 more 1 eighths, I can see that this is 8 eighths plus 1 eighth is 9 eighths. So that's where my 9 eighths come from. So I keep my denominator, and then I add my numerators. 2 plus 7 is 9, and there's my 9 eighths, 8 eighths plus 1 eighth. And then I add my whole numbers. 1 plus 1 is 2. Now I end up with a sum of 2 and 9 eighths. Now I realize I cannot leave this fraction as an improper. So I need to look at my 9 eighths, and I've got to think to myself, how many 8 eighths can I get out of there? I can get 1 whole, and that's what that is. That's 8 eighths. That's that 1 whole coming out of the 9 eighths. And then I have 1 eighth left over. Now 1 and 1 eighth is not my answer. Okay, I cannot forget about the 2 wholes that I added from up here. So I have to add these holes together, which give me 3 wholes, and then I have 1 eighth left over of that. So that is how we add with the algorithm. So when we're adding with the algorithm, just to review, our denominators stay the same because those sizes do not change. And it stays the same. You can only do this when you have like denominators. You will learn next year what happens if you have unlike denominators. But right now we have like denominators. Then I added my numerators. I added my whole numbers. If I'm improper, I have to go down and figure out that mixed number. But I have to remember to add it to what whole I have here. And I get 3 and 1 eighths. All right. So now it's going to be your turn to practice using the algorithm, and you can definitely still use drawings if you need to help you with the algorithm to add fractions with like denominators.